Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's weekly contest 490. That is check digitorial permutation. So what is the problem? Problem is that you are given an integer n. A number is called digitorial if the sum of the factorials of its digits is equal to the number itself. Okay. Determine whether any permutation of n, including the original order, forms a digitorial number or not. Return true if such a permutation exists, otherwise return false. So this is a straightforward, I think, problem statement. So that means we actually have some number, suppose 1, 2, 3. Now we have to check that if any permutation of this number, suppose 1, 3, 2, then 2, 1, 3, 2, 3, 1, then 3, 1, 2, 3, 2, 1. So I have to check all of this permutation, all of these numbers. So suppose this number, actually I found that if I add the factorial of all the digits, that means 1 factorial plus 2 factorial plus 3 factorial. So if whatever, actually suppose I got some 1, suppose if it is equal to this number, then I'll return true. If it is suppose not same, so I'll go to the next permutation. Okay, next number, next possible number. So 132. So again, actually I know that the factorial will be same, 1 factorial plus 3 factorial plus 2 factorial, because the digit actually same, only we have changed the position, right? So again I'll check that whatever the sum actually I have s1 is equal to this number. So if it is equal, then actually I'll break from here and return true, that yes, I found one permutation or actually sum of all the factorials of all the digits equal to the current number. So that time I return true. After, suppose I have checked all the permutation, suppose something 213, then 231, then 312, 321. So I have checked all the permutation and still I have not found any number which actually the number equals to sum of all the factorials of all the digits. So if it is not equal to sum, then actually ultimately I return false. Okay, after checking all of the possible numbers. Correct? This is the problem statement. Now how we can solve this? So first, before solving this, so I have to think how we can solve this, right? So that means we actually have some number, suppose x1, x2, x3. This is the 3 digits. Okay, 3 digits of the input number. So first of all, what is the range of the digits? It can be, so it can be between 0 to, it can be 0, it can be 1, it can be 2, it can go up to 9, right? This is the maximum digit actually I can actually have 0 to 9, correct? So that means when actually I want to calculate the sum of factorial of all the digits, that time actually we can actually pre-calculate this value and store somewhere, right? So I'll actually store somewhere 0 factorial, then 1 factorial, 2 factorial. In this I'll store the ultimate factorial in a somewhere, suppose in an array 0 to 10. So in the 0 index, it indicates the factorial of 0. Suppose it is actually suppose 1. Next, index 1 indicates the factorial of 1. That means again 1. Next, index 2, it indicates the factorial of 2. That means actually 2. In this I will store up to index 9. Right? I actually calculate and store in server. Now this is the next. This is the one observation we can actually see that range of the digit. Now you can see here that digit actually is fixed. We can only change the position of the digits. That means sum of factorial it will be constant. Sum of all the digits, factorial of all the digits. That means suppose here actually we actually have for this number x1, x2, x3. So the sum of factorial it will be x1 factorial for then x2 factorial, then x3 factorial. Okay. Next, suppose I have changed this number x1, x3, x2. Okay, this is the next new number I have generated from these digits. So now what will be the sum of the factorial of all the digits? It will be x1 factorial plus x3 factorial plus x2 factorial. You can see that all are actually same, but we have changed the order. So ultimately this will be also same value. Suppose if I got x, here also it will be x. So this is also constant. So before generating all the permutation, we can actually calculate and store somewhere that what is the sum of the factorial of all the digits of the from the input number. Clear? So it will actually constant for one input number. Clear? So this is second observation. Now actually what I'll do, I'll actually generate all the, suppose First of all, okay, they mention many more things. I have not checked it. This note: the factorial of a non-negative integer x denoted as x factorial is the product of all the positive integer less than or equal to x. That is correct. And for 0 factorial, it will be 1. This is, we all know about what is factorial, right? So if it is suppose 2 factorial, that means 1 into 2. Correct. All the positive integer less than or equal to x. And for the 0 is exception. So for that, the factorial will be 1. Okay. A permutation is a rearrangement of all the digits of a number that does not start with 0. Any arrangement starting with 0 is invalid. Okay. So that means, so next is, I'll try to generate all the possible permutation. Suppose I actually have 1, 2, 3. This is your input number. I'll check that is this equal to our sum of factorial or not. So if it actually same, then actually return true. Return true, right? Else I'll generate the next possible number, that will be suppose 132. Correct. Again I will come to this line. I'll check that is 132 equals to x, then return true. Else I'll go generate the next number, next possible number. After checking all of the actually possible numbers, if I did not find any answer or any possible number that is equal to the sum of the factorials of all the digits, then ultimately after this while loop I will return false. This is clear. Why ultimately after this while loop I have to return false, because I have checked all the possible numbers I can generate from this input number, right? But I have not found any number which is actually equal to the sum of factorial of all the digits. That's why I am returning false. Clear? So this this problem is not actually you can also solve this before solving this problem, that generate all possible permutation. You can actually solve that problem first, then actually you can come to this problem. But you did not actually, like, kind of not, this is not a blocker, that you first you have to know this algorithm, how actually you can generate all the possible permutation, because there is already one inbuilt function actually we have in C++, that actually if I call this next permutation, okay, and if I pass the actual array, so it will actually give us the next sorted in this lecture will sorted order, so it will return the sorted next number, next possible number. Okay, so that's why this is not a blocker, but you should actually solve this, that how actually you can generate all the possible permutation. Okay, otherwise you can actually call this next permutation number. Okay, this is clear now. So suppose I found one, this next permutation will give me one number, suppose 1, 2, 3. So this is a valid number because this is not starting with 0. They mention that if it start with 0, if any number start with 0, that is not valid. Correct. So we cannot just compare them. So that's why it is valid. This is not starting with, because the starting is 1. So this is actually valid. So I have to compare this is actually same equals to s or not. Else I'll come to the next number. So each number, for each number I have to check that also, right? This is a valid number or not. Suppose we actually have 1, 0, 1. Okay, so this is actually valid. Okay, next I will get 0, 1, 1. This is actually valid? No, because this is starting, it starts with 0, so this is not a valid number, so I cannot compare. So I'll actually try to generate the next possible number. Clear? 1, 1, 0 suppose. Okay, this is a valid number, so I'll check that is 1, 1, 0 equals to s. Okay, so now it will come to the code. So the approach is clear, right? How should we can solve this? Correct. This is kind of actually straightforward. Actually, problem is kind of straightforward. So that's why I have to know that first we will pre-calculate all the actual factorial value of 0 to 9, because our digit range can be 0 to 9 only. So that's why I will take an array of size 10 and initialize with 1. Okay, because if it is size 10, that means index value can be 0 to up to 9. Correct. And now actually start from 1 and I can go up to 9. Okay, and for factorial of I, it will be factorial of I minus 1 into current number I, because what is factorial I? Suppose factorial of 1, so it will be factorial of 0 into 1, and factorial of 0, it is actually, they mention that for 0 factorial it is actually 1, so 1 into 1 it is 1. Now factorial of 2, it is actually factorial of 1 into 2, So this is actually 1 into 2. So this is 2. Why? Because ultimately what is factorial 2? That is actually 2 into 1. So I have already calculated the factorial of, what is the factorial value of 1? So that's why I'll get from the factorial of 1. Got it? And I will multiply with 2. Similarly for factorial 3, you just observe this. So what is 3 factorial? It is actually 1 into 2 into 3. So for factorial 2, I have already calculated 1 into 2. So I don't need to calculate all of this. So I'll just take the value of factorial 2 into 3. Clear? So, so this for loop actually calculate all of this factorial value of 0 to 9. Okay. Now, actually calculate the extract all the digits. Why actually need the digits from the input number? Because I have to calculate the sum of all the factorial of all the digits, right? So that's why I'll store all of the digits in this vector, in this array digits. Okay. So I'll take another variable temp. So you can actually also know how actually we can actually find out extract all the actual digits from an input number, from any input number. So this while loop will run if it is greater than 0. So I'll actually take the modulo of 10. Okay. Suppose 145. Suppose this is 145, and what is the last digit? It is 5. So how actually can know what is the last digit? So it will be 145 modulo of 10. It is actually 5. Okay. So this is temp modulo of 10. Okay. And what is the next number? I have already extracted 5. So next number it will be actually 14. So this I will get from 145 by 10. So it is 14. Clear? Because I want to know what is the next digit. So that's why I have already extracted 5. So that's why I do not need to store that. So I'll actually remove this. So that's why I just divided this 10. Okay. Next remaining number is 14. So it will continue up to when actually I actually have some digit. That means the temp is greater than 0. So that's why I'll extract from the digit. It will be whatever the number actually I have, modulo of 10. And for the next number, I will divide by 10. Got it? So after this while loop, in this array digits, actually I have all the digits present in the input number n. Okay. Now I have to generate all the possible permutation, right? So that's why first of all sort the digits. Okay. And total factorial means sum of all the factorials of the digits. So that's why it is initially 0, and I am actually iterating all the digits because this is constant. Correct. The second observation of was what? That our sum of the factorial of all the digits, it will be same, because we can only change the position of the digits. We cannot change the ultimate digit, right? So that's why sum of the factorial of all the digits, it will be same for all of the time, right? Throughout this time, throughout this function, right? So that's why I'll actually iterate all the digits, and I'll actually check what is the factorial of this current digit I, whatever the digit actually I have. So I'll call this, and I'll store this into this total factorial. Okay. So after this for loop, I actually in this total fact value, in this variable actually I have the sum of the factorial of all the digits. Okay. Now I have to check that do you actually have any permutation or any number which actually equal to this total fact, right? This total fact is the sum of the factorial of all the digits. So I have to check that this is actually same or not, right? Any permutation, determine whether any permutation of n forms a digital number. Digital number, what is digital number? Sum of the factorials is equal to the number. So that's why this actually I want to calculate this. So that's why I have to, first of all I have to check that this actually valid number or not. So when actually to be valid, if the starting digit is actually 0, that means this is not a valid number. So I'll continue. I'll try to generate the next possible number. Okay. Else I have to check that I have to actually generate the next current number. So that's why current number is 0, and actually iterate the digits. Okay. So I multiply with 10 plus I. Suppose we actually have digits as 1, 2, 3. So what is the number ultimately? I know the ultimate number, it is actually 1, 2, 3. Correct. So I'll start with current number as 0, and first digit is 1. So I'll multiply with current into 10 plus 1. That means actually 1. So again I'll go to the next digit 2. So that means I have to place, I have to shift this left side. So how actually can shift this a number left side by 1? If I multiply this with 10, so if I multiply this 10, that means current into 10 plus 2, that current value is actually 1 into 10 plus 2. This is actually 12. Okay. Next 3, this is the third number of digit. So again I have to create a new space, new digit space, right, in the right hand side. So that's why I have to shift all the digits in the left side by 1. So how will you do that? I will again multiply this with 10 plus 3. So 120 plus 3, 3, clear? 123. This is clear. So when actually I am adding a new digit, I have to shift all of the digits by left side by 1 because I have to create a new space. So that's why I have to shift all by 1. And then this is 120. Then actually add this current digit. Clear? So in this I will create this current new number by using this actual order. What are the current order actually I have? So that's why we iterating the digit. And what are the number actually I have? Current number into 10 plus I. Okay. So if current number equals to total fact, if current number is equal to, then it will be the digitorial, right? If it is equal to same, current number is same equals to the sum of the factorial of all the digits, then it will return true. Clear? Else we have not, this current number is not equal to total fact. Again I have to go to the next number if possible. If we have already checked all the numbers, then I will break from here this loop and return false ultimately. So that's why if it is still actually have some number, so I will call this function next permutation. Whatever the digit actually I have, I will pass that. Okay. And in this actually I will check all the actually permutation, all the possible numbers possible from this input number, and for each number I will check that this is actually equal to this total factorial or not, or sum of the factorials or not. And ultimately after checking all of the number I will return false. This is clear. So what is the time actually for this? So here actually this is constant time big of 10. Okay, because 10 digits are possible. This while loop will run on the number of digits actually I have. So what is the length? It can be 10 to the power 9. So 10 to the power 9. So 10 to the power 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So length can go up to 10. So length can go up to 10. So this is also, it will run up to 10 times. This while loop will run maximum 10 times because our value can go up to 10 to the power 9, and we are actually extracting on the digit. So how many digits can be possible? Maximum 10 digits are possible. Here actually you can see this is the maximum number. I can actually have 10 to the power 9 and length is 10. So that's it can run maximum, it can run up to 10 times. Then actually sort this. So again it will be actually n log n, but this is a constant because the how many digits are possible? 10 log 10. It is actually very small actually, correct? Again I am iterating all the digits. So it will take big of 10 because how many digits are possible? 10. So this is also constant. Now this while inside this while loop, again I am iterating all of the digits. So this while loop will run 10 times maximum 10 because maximum 10 digits are possible. And this next permutation will be called. So next permutation it will take big of n something or n square it is possible. Okay. So it will actually work, right? Because it is very small compared to 10 to the power 8, right? Maximum it is like 10 to the power 8, but it is very small actually, right? So I have shared this code in the description. You can check that. And also, if you have any doubt, any suggestion, you can comment on that. Okay. And also, if you like the video and if you like the explanation, also please like the video. And if not yet subscribed, please subscribe channel. Thank you. Bye bye. See you in the next video.